This is a video of me going over the study guide for the performance final for this fall. So up here it says in the figure A is parallel to B, so we're going to put some parallel symbols on these two lines because that's going to be relevant as we work through this problem. Then it tells us the measure of angle 1 is 35, so we're going to put 35 here. And it tells me the measure of angle 2 is 80, so I'm going to put 80 here. Then I actually see a couple ways we could go here. First of all, I see that angle 1, 2, and 3 form a line, so I know that a line's measure is 180 degrees. So I'm going to find angle 3 at this point. I'm going to add 35 to 80, and that's going to give me 115. And then I'm going to subtract that 115 from 180. So 180 minus 115 is 65. So that tells me that angle 3 is 65 degrees. So then I see these vertical angles here. So I notice that angle 1 here and angle 6 here are vertical angles. So this one's 35. I notice that 2 here and 5 here are vertical angles. So this one's 80. And I notice that this angle here and this angle here, 3 and 4, are vertical angles. So this is 65 degrees as well. Now, as I look through this drawing, there's a couple other things that I can see. First of all, when I have a couple properties here that I could use alternate interior angles here, and I could use exterior angles. Well, so first of all, let me see if I can show you this. I notice that this angle right here is an alternate interior angle to this angle down here. So if that angle up there is 65, then this angle right here is 65. Then I could solve for 7 by subtracting 65 from 180. So 180 minus 65 is 115. So that means that 7 is 115. And again, we have some vertical angles here. So angle 8 and angle 11 are vertical angles. So this is 65 degrees down here. 115, 7, and 12 are also vertical angles. So that's 115 as well. So now let's move over here to the right. So here again, we do have some vertical angles. So when we look at angle 9, so this angle here and this angle here are vertical angles. So 9 is 35. And because 9 and 14 are vertical angles, we could say that 14 is 35. Then again, we can see that 9 and 10 form a linear pair. So we could do 180 minus 35 for angle 10. And angle 10 is 145 degrees, which means that angle 13 is also 145 degrees because they are vertical angles. So now all we have to do is go in and fill our blanks because we found every angle. So the measure of angle 3, for example, is 65. We have the measure of angle 4 over here is 65. The measure of angle 5 is 80. The measure of angle 6 is 35. The measure of angle 7 was 115. The measure of angle 8 was 65. 9 was 35. 10 was 145. 11 was 65. 12 is 115. 13 is 145. And 14 is 35. Those are the answers to all of this first part of this problem. Now, when you get to the third part of this problem, you're going to have to explain how you got these angle measures. You're going to have to pick 3 of them. And just like I explained how I got them, you're going to have to explain how you got them. So the next part of this problem asks me, what are all the pairs of the following angles in the diagram? So Corresponding angles are angles that are in the same side of the transversal and on the same side of the parallel lines. And these we can see too because they are congruent. So the first set that I see here are 1 and let me see, 1 and 9, because they're on the same side of the transversal and the same side. So if you notice 1 here and 9 here, they're on the same side of the transversal and the same side of the parallel line. Then we've got 3 and 8. So 3 is here and 8 is down here. So we've got 3 and 8. That's another pair of corresponding angles. Then we've got 4 and 11. So 4 is here and 11 is down here. Same again. 4 and 11. And then we've got 6 and 14. So I'm going to go back to, actually I'm going to, let me see. I'm going to do this in red as well. So 6 is here and 14 is right here. Those are corresponding angles. Okay, then we've got alternate interior angles. Now alternate interior angles are angles that are on either side of the transversal but inside the parallel lines. So over here, I'm going to use green for this. So we've got the 65 here on one side of the transversal, this angle right here, y'all. And then this one down here is on the other side of the transversal. So those are 4 and 8. And then we've got another pair, which is 6 and 9. So up here, we've got angle 6, this angle right up here. And over here, we've got angle 9. Those are on opposite sides of the transversal and inside the parallel lines. Then we've got alternate exterior angles. These are on opposite sides of the transversal, but outside the parallel lines. So our first pair here are 1 up here, top left, 35, and this one down here, this 14. So 1 and 14 are a pair of alternate exterior angles. And then we've also got up here on the upper right, angle 3 here and angle 11 down here. Those are alternate exterior angles, 3 and 11. Then we're talking vertical angles. We have a bunch of vertical angles here. So I'm going to see if I can draw these one at a time. So I've got angle 1 up here and angle 6 right there. So we've got 1 and 6. Then we've got angle 2 right here and angle 5 right there. 2 and 5. Whoops, I skipped, didn't I? So I had 1 and 6 and 2 and 5. Sorry, I'll go back to that other one. 1 and 6, comma, 2 and 5. We'll go back up to the same side in a minute. Okay. Then we have, okay, so let's use green over here. So then we've got this pair right here of vertical angles. So that would be 3 and 4. Got some more down here. So over here, we've got 7 and 12 are vertical angles. 7 and 12. And by doing what I just did, I see another pair, 8 and 11. Now those are not the only ones. We got some more over here on the right. So we've got, if you notice here again, I'm just going to draw these 2 lines. Y'all see those 2 lines I just drew? So we've got the 35 over here and the 35 over there. So that's 9 and 14. 9 and 14. And then we've got 10 and 13. Okay, so now let's go back to same side interior. So we've really, when we talk about same side interior, they're on the same side of the transversal and inside the parallel lines. And these are always supplementary. Everything else we've been dealing with is congruent so far. So if we're looking at our same side interior angles, we've got this is our transversal, this is our parallel line right here, and this is our parallel line right here. So we've got the angle 115 and the angle 65. So that's 4 and 7 that are same side interior angles. And then over here on the other side, same sort of thing. We've got this line in our transversal here and that line right there. So we've got 145 and 35. Again, if you add those together, those are 180. So those angles are 6 and 10. All right, so our last pair are linear pairs. Now, I'm going to actually erase everything we've got up here because it's gotten pretty messy. And we're going to talk about our linear pairs here. Now, linear pairs are two angles that form a line. Again, in this drawing, we've got a bunch of them, so we're going to talk about them. So these two angles right here form a line, so those are 7 and 8. Then we've got these two angles right here that form a line, 8 and 12. Then we've got these two angles right here that form a line, 11 and 12. And again, right here, we've got 7 and 11. Same thing over here on the right. We've got 4 more pairs. So we've got 9 and 10, 13 and 14 there. 9 and 10, 13 and 14. And then when I do this line right here, we've got 9 and 13 and 10 and 14. So number 2 says first to plot the preimage rectangle QRST with the coordinates that follow, and I did that already. So then it says dilate the image by a scale factor of 1/2 and label this image Q prime R prime S prime T prime. So what I'm going to do right now is I'm going to multiply all of my terms by 1/2. So my Q prime would be 2 times 1/2 is 1, 4 times 1/2 is 2. My R prime would be 4 times 1/2 is 2 and 2. And then S prime would be 4 times 1/2 is 2, and -6 times 1/2 is -3. And then T prime would be 2 times 1/2 is 1, and -6 times 1/2 is -3. I'm going to go ahead and plot this next. So I went ahead and plotted that, and I went ahead and did it in blue, and then I plotted it in blue so you guys could see it differently, very clearly. Now part B says translate the rectangle R prime Q prime, or QRST prime, 1 unit to the left and 2 units up. So the first thing I want to do with that is I'm going to write a rule. So our rule here is going to be X comma Y is going to translate to be X minus 1, Y plus 2. And when we do this, let me go ahead and make this a little bit not as thick so I can fit it all. Okay, so now when I do this, I'm going to actually subtract 1 from all the X values and add 2 to all the Y values. So our Q double prime is going to be 1 minus 1 is 0. 2 plus 2 is 4. So it's going to be 0, 4. Then our R double prime is going to be 2 minus 1 is 1. And 2 plus 2 again is 4. So that one's going to be 1, 4. Our S double prime is going to be 2 minus 1, that's 1. And -3 plus 2, that's a -1. Then our T double prime. T double prime, again, 1 minus 1 is 0. And -3 plus 2 is -1. So these are our QRST double prime points. Now I'm going to go ahead and plot those. So you can see my QRST over here. It's this green one right here. That is where the final image is. And it says, is rectangle QRST congruent to rectangle QRST prime? Well, the answer to that is no, because they're not even the same size. if we look at QRST prime, it is a scale of QRST, the preimage. So part B says plot the preimage rectangle JKLM with the following coordinates, and I did that already. Then it says graph the image of the rectangle JKLM after a reflection over the x-axis. So on this one, we're going to go ahead and write this rule. And this rule for the reflection, so when we do our rule here, x, y, it's going to, a reflection over the x is a change in the y. So x comma negative y is the reflection of that point. So we're going to go ahead now and apply that to all the points. So for J prime, that's going to give us negative 6, 4, because we changed the y value. For K prime, that's going to give us negative 6, 1. Again, change the sign of the y value. L prime is negative 2, 1. And M prime is negative 2, 4. Now it says to go ahead and plot that, so I'm going to go ahead and plot that. And you can see that I plotted JKLM in green. All right, so now it says translate rectangle JKLM 3 units right and 2 units down. So again, we're going to write a rule for this. We're going to do this one in blue. So our rule, y'all, is going to be, sorry about that, x comma y, it says 3 right, so that's x plus 3 and y minus 2. So now we're going to apply this to all our points. So our J double prime, when we do negative 6 plus 3, that gives us negative 3. We do 4 minus 2, that gives us 2. So our K double prime, 6 again plus 3 is negative 3. I'm sorry, negative 6 plus 3 is negative 3. And 1 minus 2 is minus 1. Then we got L double prime, negative 2 plus 3 would be 1. And 1 minus 2 is negative 1. And then our M double prime, negative 2 plus 3 would be 1 again. And 4 minus 2 is 2. Now I'm going to go ahead and plot these. So you can see that our final image is right here in blue. Then our final question says, is rectangle JKLM congruent to rectangle J double prime KLM double prime? And because all we did here was flip it and move it, it is congruent. So the answer to this is yes, it is congruent. Okay, so this one, I've already plotted the image of ABCD. And it says graph the image of the rectangle ABCD after rotation of 90 degrees clockwise. This says 90 degrees clockwise right here. That's a relevant point because normally we do counterclockwise. So 90 degrees clockwise is 270 degrees counterclockwise. So that's important to say because we have to write a rule for this before we do anything else. So let me make sure I have a skinny pencil. All right, so let's write our rule. X comma y, and that rule for a 270 degree rotation, if when it's 90 and 270 we flip the y and the x, and then we think about what quadrant it is. When it's 90 degrees counterclockwise, it's in quadrant 2. However, when it's a 270 degree clockwise, which this one is, counterclockwise, sorry, then it's in the bottom right quadrant. And so 90 degrees quadrant also puts it in quadrant 4. So we're going to flip it there. And so now we're going to apply this rule to our points. So we've got A prime, and when we flip them, it would be 1 comma negative 1. B, we're going to flip them again. It's going to be 1 comma 6. Now this 6 is going to become negative. And then C prime is negative 2, negative 6. And D prime is -2, -1. Again, flip them and then change the sign of what is in the y position. Let's go ahead and plot this. So now our green image, as you can notice, has been rotated 270 degrees counterclockwise, or 90 degrees clockwise. Then part B says translate the rectangle ABCD prime 2 units to the left and 1 unit down. So here again, we are going to write the rule first. So the rule here for 2 units left, so we're going to go x comma y. 2 units left would be x minus 2, and 2 units down would be y minus 2. So now we're going to apply this to our points. So now we have a double prime, and a double prime is going to be -1, -3, because when we subtract 2 from 1, we get -1. And when we subtract 2 from -6, or from -1, sorry, we get -3. So b prime, b double prime, is we're going to do the same process, -1 comma -8. C double prime, -4 comma -8. And D double prime, -4 comma -3. So again, what we did here was we subtracted 2 from all the x values and we subtracted 2 from all the y values. Now I'm going to go ahead and plot this so you can see the final image. So now you can see our final image over here is in blue. And if you notice, again, our process. So we first rotated it, which doesn't change the size of the image, and then we translate it, which doesn't change the size of the image. So yes, rectangle ABCD is congruent to rectangle ABCD prime. So the answer down here is yes. So now we're on part 3 of the review. And it says a lifeguard is standing at point B, and he is 50 feet away. So point B is down here. He's 50 feet away from the shoreline at A. So he's 50 feet away from there, and it shows us that in the drawing. And 30 feet away from the lifeguard stand. So this is the lifeguard stand right here at point E. A lifeguard looks across the water and sees a swimmer at H and a shark at C. So it says, how far is the swimmer from the shark? So first of all, if you notice out here that we've got 40 is congruent with 40, and we have that 50 is congruent with 50 here. So we know that these two triangles are congruent because of side, angle, side. So as a result of that, if we know that the shark, it says here that the lifeguard looks at the water and sees swimmer H and shark C. So we're talking about these 2 points. How far apart are they? And down here, because these two triangles are congruent, we can say that BE is congruent to CH. So that means the shark is 30 feet away from the swimmer. Again, so we are looking at how are those two triangles congruent. We could tell that they were congruent because of side, angle, side. Thus, we could say that the part BE is congruent with the part CH. So BE, again, is congruent with CH by corresponding parts of congruent triangles are congruent. All right, so let's go to this next part of this problem. So part B says the town A and town B need to have a road built to get from one to the other. A bridge can be built over the lake or a road around the lake through point E. The roads intersect at point E. The line joining towns A and B, A to B is parallel to the line. So that we're going to go ahead and draw that on this drawing first, that these two lines are parallel, because that's going to be relevant as we work through the problem. Now, I notice that the triangle on the bottom is smaller than the triangle on the top. So what we need to do is figure out if there's a way that we could say that these two triangles are congruent. Well, first of all, we know that these angles are congruent because they're vertical angles. That would be our first point. And then we also know that angle D is congruent with angle B down here because of alternate interior angles. We could also say that angle A here is congruent with angle C here for the same reason, because they're alternate interior angles. So these two triangles are similar by, the triangles are similar. So actually, let's do it this way. Let's say triangle ABE, triangle ABE is similar to triangle CDE by angle. Now once we have that, we can determine the distance. And the way that we're going to determine the distance is by using ratios. So if you notice over here that AE first and last letters, AE map to CE. So that would be 12.6 over 3.2. And then we also have that we're trying to find out how far apart the towns are. So up here on the top, we have that DC is 5 miles apart. So we're trying to find how far A and B are. So we're trying to find A to B here. So we're going to put the 5 down here because that's the corresponding part. AB over CD. All right, so now we're just going to cross multiply. So that's going to give us 3.2 AB, which is equal to 12.6 times 5. Now when we do that, we're going to get 3.2 AB equals 63. I'm going to go ahead and work this down here and I'll erase it afterwards. So 3.2 AB is equal to 63. Then we're going to divide both sides by 3.2. So AB is equal to 19.7 miles. So that's how we do this, by setting up a ratio of corresponding parts in the similar triangles. So the second part of this problem says determine the distance from town A to town B around the lake through point E and around to the 10th. So this means that we want to, it says we're going to go through point E. So if we went around this, we need to find out basically the length of BE as well. So we're going to take what we know, which was 12.6 over 3.2, and we're going to compare that to DE, which is 3. Sorry, put that on the bottom. 3, and we're going to find out what EB is. So here again, we're going to cross multiply. So that would be 3.2 EB is equal to 12.6 times 3. And when we work that all through, we're going to get that EB is equal to 11.8. So to solve this part of the problem, we're now going to have to add those two parts together. So we're going to have to add the 12.6 here to the 11.8 here, because we can't go over right now the lake because we don't have a bridge. So we're going to do 12.6 plus 11.8, and that equals 24.4 miles. Now for this third part of the problem, I'm going to actually label some of the stuff we've already found. So over the lake was 19.7 miles. And this over here to the right was 11.8 miles. And the reason we're doing this is because this third part says if it will cost $4.1 million per mile to build a road around the lake and $5.6 million per mile to build a bridge over the lake, which would be cheaper to build. So we're going to basically multiply these by our numbers that we just got. So if we're talking about over a bridge, so if we're talking about building the bridge, that would be 19.7 times the 5.6, and that is 110 10.32 million. And if we're talking about going around the lake, that was the other length that we found, which was 24.4. So the 24.4, and it says if we do that, the road, it's 4.1. So then we're going to multiply that, and we're going to get 100.04 million. So which one of these is cheaper? Obviously, to go around versus building the bridge.